the major direction that Ethereum is going in is going to have higher data availability throughput to support a number of rollups on top. We zeroed in on using this combination of KZG polynomial commitments and validity proofs to implement the data availability layer and the data availability sampling. The Avail DA, which is the first component that you speak of, is the only project in the space at the moment that has implemented data availability sampling with validity proofs.
Welcome to the Bare Metal Podcast.
Hey everyone, thanks for tuning back into the Bare Metal Podcast. This is Shipthecode from RockawX Labs. I'm interested in the Avail project and I have Anurag here to tell us all about it. Welcome.
Yep. Thanks, Martin. Looking forward to talking to you.
So first, can you give us a short intro to yourself and how you came to build the Avail project?
Yeah. So Anurag, co-founder of Avail, previously co-founded Polygon back in 2017. Before entering crypto in 2017, spent about 11 years in various product and engineering roles, primarily in fintech and regulatory technology. 2017 entered the space, founded Polygon, which was known as Matic back then. Built a lot of the stack there, including Polygon POS, the Plasma solution that we started with, a lot of the bridging infra, crafted a lot of the ZK strategy there, which led to acquisitions of teams like Hermes, Zero, Maiden, and so on. And actually, started Avail within Polygon back in 2020. And just last year in March 2023 is when we spun Avail out of Polygon. So I left all operational roles at Polygon and have been focusing on Avail full time since March 2023. So that's the rough background, but happy to get into more details.
Right, I'm super interested. So the Polygon history makes it all the more interesting because Polygon also has different types of proof aggregation and stuff. So I'd love to get into that and what's the positioning and how you guys planning to sort of work together or not work together. So let's take it from the bottom. Like Avail, very big project. I would call it full stack in the sense of there is a data availability layer, there is a sequencing layer above that which uses CK-Tech extensively, and then there is another product with fusions called Fusion Security, which allows restaking or shared security. So that's a lot. I was hoping to take this from the bottom to top because I think the bottommost stacks are easier to understand. Then we can build on top. Sort of what other things? How does that combine with, say, the DA or with Nexus? So, can you tell us about how you guys designed the DA layer? If you can compare it to something like EigenD or Celestia, like what are your choices? Why did you decide to do that? Let's take it from the bottom.
Yeah. Just before I get into that, the Nexus layer that you refer to, it's not really a sequencing layer. I mean, it does sequencer coordination and proof aggregation primarily, but we'll get into that later. But starting from the DA layer, right? We started Avail back in 2020, late 2020, and just to give some context, right? At the time, Ethereum had announced the rollup centric roadmap. So they had left the execution sharding roadmap that was there, and we're moving to the rollup centric roadmap. And so essentially we kind of looked at, we were, of course, at Polygon, we were already building a Plasma solution. Then of course we pivoted to rollups. But we were, if you kind of remember Plasma was this off-chain execution, off-chain data availability sort of a construction. And that didn't really pan out because there were various problems with having data availability off-chain, trying to kind of, get the interactive game running on-chain, for example, and so on. So that experience, helped us understand a lot of things much more deeply. And so when, rollups first started coming into the picture, we intuitively understood that this is like a paradigm shift in how blockchains are going to get built, right? Before rollups, the way blockchains were created is that there used to be this execution environment with, let's say certain VM, for example, and then you have to construct like this L1 thing where you have to have their, like a validator bootstrapping phase, cryptoeconomic security bootstrapping phase, like, so you need to have a, like number of validators, you need to have a token. The token should be valuable enough to ensure cryptoeconomic security and so on. So essentially, of course, Ethereum started off with being one of the first general purpose blockchains out there. But the experiments that you see after that is basically variants of that with probably faster blocks, bigger blocks, and so on. That happened for a long time, and then of course, like the years 2017, 2019 is when you had these newer sort of blockchains with efficient VMs, for example, like Solana, for example, and like maybe now Aptos and Sui. So those kind of things, right? Like, but the insight was that you needed to experiment with newer sort of execution environments, newer sort of access mechanisms, etc. But the actual way to create a blockchain was, like creating this new execution environment and all its optimizations, but also bootstrapping this validator set and cryptoeconomic security. And so what rollups really, like promised to bring to this paradigm was to demarcate this and to kind of have this base layer where which could support potentially hundreds and thousands of rollups, and each rollups could have innovations in execution environment like the ones you see today. For example, there are Move VMs, Solana VMs, like rollups utilizing those kind of and absolutely new paradigms like Maiden VM, for example, Cairo VM, of course. But like you have some teams like Stacker doing enabling rollups that can be written in TypeScript, for example, and so on. It's like so essentially what I'm trying to kind of paint the picture before getting into why we started building out what we built was we knew that the way blockchains were going to be created was going to undergo a paradigm shift. It was no longer going to be like 1,000 L1s, which all needed to bootstrap cryptoeconomic security from scratch. It was going to be one or few base layers with this shared security model, and any rollups on top would inherit the security of the base layer. So that was the primary insight we began with. And of course, Ethereum took that approach, which is very different from other blockchains who are trying to do faster, like VMs, for example, or faster throughput, for example, and so on. And so, in general, it was very clear that we were going into the roll-up centric roadmap for blockchains in general as an industry. I think, and that has only become more true and true as we go forward. Like from the 4 years since the roll-up centric roadmap was introduced, we've had like at least 10 to 15 different roll-up stacks already like in production or on being developed, but more coming on the way. And actual instantiations of rollups have been crossing, I think, maybe 200 to 300 already. Even on L2bit itself, you can see probably 100 rollups. The insight is that like chain developers can now take a rollup stack and then just bootstrap their chain because the cost of spinning up a chain has gone very low. So if you look at something like Base, for example, Base did not do major chain development. It basically took the OP stack code and then basically created a new chain called the Base chain. And what they've been focusing on is more on the business part, on the user acquisition part, on the GTM part. And so essentially, that's a major shift in how in kind of like lowering of the cost of spinning up chains. And by I mean, of course, right now all the focus is on EVM rollups, but being a rollup frees you from from a specific execution environment. You can be EVM, it can be SVM, it can be some custom state machines, for example, and so on. So essentially, sorry, I'm getting into this big monologue, but essentially this was the context which we began. And in this world that we saw, we thought the what could be a construction that really supports and enables this roll-up centric future. So that really is what the Avail protocol really is. So we started off with this base layer, which provides data availability, and essentially data availability is a very um, or misunderstood term, right? Like it's really we do consensus and ordering for various blockchains on top, right? Like so these are rollups are blockchains of them of their own, and essentially what we maintain is the ordering of transactions from rollups, and of course we make data availability verification very fast, very efficient. So we looked at few key insights on when we began with the design, right? Like what would be the most optimum design or more future-proof design to do this? And essentially, we zeroed in on using this combination of KZG polynomial commitments and validity proofs to implement the data availability layer and the data availability sampling. More importantly, the data availability sampling component. The Avail DA, which is the first component that you speak of, is the only project in the space at the moment that has implemented data availability sampling with validity proofs. And Ethereum has kind of similar plans of doing data availability sampling with validity proofs, and they also want to are going to use KZG polynomial commitments, but that is on the dank sharding roadmap, and the dank sharding roadmap is going to take a little time. Of course, Ethereum is a production network with probably more than $400-500 billion in value, and it is necessarily slow to upgrade in that sense. And we thought that the roll-up centric future was already going to come pretty soon, and it has already come. And we wanted to enable that infra for roll-ups. Just to kind of give some differences, since you asked about other solutions, like Celestia does a optimistic implementation, like a more fraud-proof based implementation. It uses interactive fraud proofs for their data availability sampling implementation. And we use validity proofs, and the differences are, I mean, it's kind of similar to how, like optimistic rollups and ZK rollups work, right? Like, I mean, optimistic rollups need to have this challenge window period for the interactive challenge, which, like Celestia has for the fraud proof, the data availability sampling encoding checks. We utilize validity proofs, and so it's similar to what Ethereum wants to do on its land sharding roadmap, and so we have faster final data availability verification guarantees. And IDENTIA is basically like a committee. It doesn't have any data availability sampling. It's a committee powered by restaked ETH. Those are the rough differences. But happy to get into more details.
Right, so EigenDA would be just splits a block or a batch, as they call it, into chunks, right? They send it to many hosts there, and they're hoping the host will retain the data and serve it on demand because they are slashable if they don't. So what do you think is the relative cost of these designs? Like, do you think you incur more cost if you were, building validity proofs per block? If I understand correctly, you guys build these validity proofs for every block, right? Does that somehow make this more expensive? How would a project approach choosing a DA layer among these choices?
So essentially, like you have to kind of see, like there's a lot of design trade-offs that you can make, right? Like so Ethereum, when it implements data availability, so EIP 4844 came a couple of months before, and what they've done is basically introduce this blobs on the beacon chain, and those are like those use like partly the commitments on which in the future when dank sharding goes live, like validators will be able to verify these validity proofs. Now, these commitments or the proofs to check the encoding checks, these are very lightweight ZK circuits that we write, right? Like, so we write very specialized. So this, I want to just kind of differentiate these from, let's say, things like ZK EVM proofs. Like ZK EVM proofs are much more like complex, heavyweight like it takes a lot of time to generate.
The verifier on chain would use a lot of gas. That's sort of is that a fair way to look at it?
It also takes a lot of time to generate. Like for
Right.
example, like
So high
because
latency.
those this that is you can think of that as a really big circuit with millions of cycles. What we do is we do a very specialized checks so that we can check the data encoding has been done correctly or not. And this is a very lightweight circuit. Like we can do, um, like our block generation, uh, like the generation time is in the milliseconds in that sense. The
Right.
commitment generation time is a few seconds. The generation and verification times are a few milliseconds. So it doesn't. It's basically more about future proofing the solution, and that's after a lot of iterations. That's the direction which the Ethereum folks also came to the using the same technology, and I think using like I mean, of course, I'm biased, but like using fraud proofs is going to like it's going to create problems in terms of interoperability and so on.
In terms of delays that you have to wait for until you can rely on the data, which means bridging could be slower. I see that. I think the key observation here is you're right. When we think about ZK, we usually think it's going to be heavy, computational intensive, maybe using GPU, therefore infrastructure, intensive, power intensive. But what you're saying is that's not really a problem for the Avail DA layer because it uses very specialized Morse secrets that are quite quick, and so most of the computational time is spent in building the KZG commitment, and then everything that follows from that is
Yeah,
fast.
yeah.
I
And
saw
even
on the
that is
website.
fast.
Yeah.
Even that is fast, right? Like I mean, it's yeah, like on a consumer like most of our validators run probably 8 GB or 16 GB RAM machines with like it's like regular machines, and for them it takes probably like in the seconds to generate the commitment.
I saw you mention, or the website mentioned elastic blob space. But what do I understand under that? Like, can Avail DA somehow inflate? Can you leverage more compute on demand, or in what sense is blob space elastic? Because that affects also the price, right? In case there is more projects. So
No, no, absolutely, absolutely. See, that's fundamentally why we kind of took this foundational approach to designing Avail DA with these attributes. Because see, like people view like again as I said, data availability is massively misunderstood. Like what data availability really is, it is basically the ordering as a service sort of a blockchain, right? Like I mean, today rollups use Ethereum as for data availability. But of course, also most rollups have a bridge to Ethereum as well for assets, for example, but also for things like proof verification and such. But the major direction that the Ethereum is going in is going to have higher data availability throughput to support a number of rollups on top. Now, why do we come to this design? Like, why don't we do why why are we not doing like new L1s and why are we bifurcating the element of data availability from execution? The rollup construct is this bifurcation of execution and let's say data availability. Like the execution is offloaded to the rollup, which is off chain, and the remaining attribute is consensus and ordering, right? Like or data availability, right? Like so and so because we have only so we are not a smart contract blockchain. Like our execution runtime doesn't have smart contracts. We don't execute any user transactions. So the reason why, because if there is only it's a data availability focused blockchain, we don't really need to re-execute transactions, for example, and so on, right? Like we just need to do the bare minimum that is required, which is basically getting in transactions from rollups, packaging them all together. We do this. Our particular implementation does this 2D matrix, for example, and then creates the commitments and so on, right? Like I mean, finalizes the block. Now, the beauty of this design is we are able to increase this 2D matrix size. So if we use this matrix of 256 by 256, the block size is a certain size. If we increase the matrix, it becomes, like bigger. So we can have 2 MB, 4 MB, 8 MB, 16 MB, 32 MB. Like we have tested benchmarks up to 128 MB, for example, and all of them fall within our, like block time. And so essentially, because we don't have the overhead of execution, we are able to now have bigger blocks. That is the main um, unlock that you get from bifurcating execution and data availability. Because big blocks in conventional L1s was a big problem. Like let's say Binance Smart Chain or whatever, right? Like I mean, if you want bigger blocks, it leads to a lot of downstream problems. Here, the design itself is basically so that we can scale block size essentially, and doing this we don't really increase requirements from a verification perspective massively, right? Like of course validators need to have more hard disks space, for example, but the increase in compute is only slightly higher. But like the verification, as I said, from a light line perspective, it remains the same because like if it's a 256 cross 256 matrix, and if we increase the matrix size, the proof that the light lines verify still is succinct, very small, for example. So
So is the matrix still based on read Solomon codes, just like in the Celestia case, where you sort of move data around to make redundant? Okay, to identify, and the second thing that I guess also we should mention in the case of DA, which is often misunderstood, data availability makes the data available for only a limited amount of time, right? Which is why your validator need bigger drives, but they don't actually grow with the storage of the whole blockchain. They don't store the history. So I think I've never heard anybody really, I think only one episode of this podcast, someone was really thinking about storage costs and who's going to, like, if you increase the state growth, it's got to be stored somewhere later. I mean, if you want to have chain history available, this ledger that we keep talking about. And I don't know who's going to store all that data later. But I guess it's the key thing to observe here is that's not the problem of the data availability solution, right? The data availability solution has to sort of vouch for that data for a particular period of time to facilitate interoperability, right? But then somebody else has to offload this data and sort of store it and take it, which I guess makes this a uniquely scalable product as I
yeah,
feel you're pointing out.
absolutely. See, basically, it's essentially rollups. Either like you primarily use validity proofs or fraud proofs. And validity proofs typically are quickly, like the execution is quickly verified. For optimistic rollups, there is generally a bigger challenge period, like 14 days, for example, 7 days or 14 days, depending upon the implementation. And so really, that is the time when like when you have the data available. Yeah, so data availability is slightly different from data storage, very different.
I think that's sort of we looked at the differences between the Avail DA and sort of these other competitors, but we haven't compared it to Ethereum. So what do you think happens to Avail DA as a sort of like a platform of choice if when dank sharding comes online and or like you can sort of store and commit to the well, maybe not store but commit to the data basically in much cheaper way for a much cheaper price on Ethereum than today. Do you think that affects somehow the how projects are going to pick their DA solution?
So a couple of things to like to note here. Like one is I think dank starting is still a few years away. So in general, rollups need a solution today. So certainly Avail provides that solution. So that is one. Second is like if you see our roadmap, beyond Avail DA, this is like what we call the other components of Avail Nexus and Fusion. Um, Essentially, what we believe is that certainly we are moving into this rollup centric future. There's going to be hundreds and thousands of these rollups, and not necessarily EVM rollups, right? Like I mean, there will be very specialized, very app specific rollups and such, right? Like there's a lot of tooling that is underway, and essentially, if you kind of look at the landscape at the moment, right? Like the user experience fragmentation is massive at the moment. Like even if Ethereum ends up handling like these, having enough throughput capacity for all these rollups, you still have to kind of build interoperability for these rollups to talk to each other, because otherwise you have to go through Ethereum. You have to go through Ethereum from one rollup to another, for example, and that increases cost massively. Now, why are we building Nexus, which is the second component that we are building, right? Like, I mean, see, if you kind of look at it, how can two blockchains really talk to each other, right? Like in the most trust minimized manner possible, right? Like, so historically, if you've seen kind of bridging solutions, these are typically between two different L1s, for example, and so there will be like on the extreme end, there are light IBC like light clients, for example, that like listen to consensus verifiers for each blockchain on each side, for example, and then do the communication. And of course, the on the extreme side, there are these more multi-sig bridges, or like validator multi-sig bridges, for example,
POS
and
bridges
so on.
essentially, like in
Yeah,
slashing
yeah,
based. Right.
yeah, slashing based bridges, right? Like so that is the landscape at the moment. But now, as we are saying, see, as I said, the way in which blockchains are being constructed is changing, and we are going into this roll-up centric roadmap. What is the best way to build um, interoperability between rollups is basically is that you already have a shared data availability layer that already hosts the rollups ordering data, right? Like, so you have a proof of the ordering right at the data availability layer. Now you kind of combine it with execution state proofs from the rollups, and so you combine the ordering, right? Like, so the ordering is important because if the ordering is tampered with, it the meaning changes. So the ordering has to there has to be a commitment to the ordering, and the because all these rollups share the same DA layer, you have the ordering in one place with a shared notion of validity, and then you combine this with like the state proofs or execution proofs, for example. And so if you kind of think of it, like someone has to build that infrastructure out, even if like Ethereum ends up finally kind of releasing their time starting roadmap, right? Like, because Ethereum is not going to get into the business of building that rails, because you still have to go to Ethereum L1, and Ethereum L1 is going to be getting more and more expensive as time goes. The execution part, I'm saying. And so, of course, like certainly, I'm saying that Avail DA is massively important for rollups today. But even after a few years, I mean, like once we kind of build out this interop infra as well, it's going to be very, very useful, because ultimately what we are betting is that on rollups being the predominant blockchain creation mechanism.
So if I sort of look at the your answer from 10,000 feet, the idea is Avail DA is still going to be attractive because there are going to be these additional services built on top that make it more of a value proposition than just using like a bare bones sort of DA layer and then building out everything else yourself. So in some sense, you guys are building the whole stack. Like Celestia is spinning off or supporting Astria, which is building shared sequencing on top of like Celestia, I guess in a similar way to sort of provide like a more valuable stack. Is that a fair summarization of the reasoning why you guys are building Nexus?
So the idea is that, so of course, see, we don't build out, like, just to be clear, we don't build out any sequencing infra. Like Nexus, the second component that we work on at Avail, does this more lightweight ZK verified protocol on top that essentially does two things. It does proof aggregation and it does sequence selection. The proof aggregation is basically it's and I will kind of
Sorry,
try to talk
can we
about.
take it from the top? I think this is going to be hard to understand. If we think about like, can you point out if there are multiple rollups and there are in Nexus? Like, what does that look like? Do they each come in with their sequencer that somehow has support for Nexus protocol? Can you sort of, let's imagine there are 4 different rollups. Can you take us through it? Like, what do they need to bring? How are they using Nexus to talk together?
Yeah. So basically, I mean, so we are doing this. We are close to kind of launching the first MVP of Nexus probably in June or July. This is going to showcase interop between a ZK sync chain and a ZK EVM chain, a Polygon ZK EVM chain. What it does really is it takes a proof from the validity proof, the ZK proof from Polygon ZK EVM, for example. It takes one from ZK sync at regular intervals whenever the prover, like we don't do any of the proof generation, that we leave it up to the rollup essentially. So right now what these rollups do is they periodically post these proofs to Ethereum on a contract. But these proofs can be generated much faster as well. It's just that the on-chain Ethereum on-chain verification cost is pretty high, so they kind of wait for a batch of transactions and then post it to Ethereum. What we do is we kind of take these proofs from these rollups, we aggregate it into one proof. And this one single proof can comprise of proofs from various rollups. It is theoretically it's n rollups, right? Like, so we of course start with a few rollups, but essentially the protocol allows for aggregation of multiple rollup proofs. Once that is there, once the aggregated proof is there, so the protocol, essentially what the protocol does is, how is the proof aggregation constructed? It basically, there is a circuit which verifies each proof. So just to keep it simple, let's say there's a ZK EVM proof and a ZK sync proof. We have a circuit which basically verifies the ZK EVM proof and the ZK sync proof, and then aggregates it and constructs like one single proof. Now this single, okay, let me take the before and let me see this like a before and after example. Like before, if like a ZK EVM, so a user on ZK EVM chain wanted to send a message to a ZK sync chain, what they would need to do is they would wait for the proof to be sent to Ethereum. They would send a message to the Ethereum contract, which then they can send a message back to ZK sync via Ethereum. What we do is add like an intermediate layer where the proof goes to Nexus. It gets verified and has a single proof. Now, because there is only one single proof, this the user here can immediately verify whether the state that came from this ZK EVM chain is actually valid and can process the transaction here. So you can think of like all of this actually could be theoretically done on Ethereum L1. We kind of introduce one layer in between, which kind of short circuits or lowers latency and lowers the cost by which interop can work.
So, yeah, the one of the assumptions I picked up is that each of the rollups that wants to take part in Nexus, that wants to be part of it, has to be a ZK rollup by itself. It has to be producing its proofs.
Yeah,
there's no provision for Nexus 2.
Yeah, so we are starting with validity proof because that's something which we are most comfortable with, because we are very ZK heavy team. So essentially we start with that, and the protocol is easier to construct. Having said that, we are working with the optimistic rollups as well to create things like storage proofs and state proofs essentially, and to also integrate those into Nexus. The protocol for that is still WIP, but theoretically it can be done essentially. But
right.
Since the ZK rollups are a little easier to do, we started with that.
And you guys are going to be extending the aggregation circuit as sort of more rollups join Nexus. The circuit would still be aggregating all of those into one proof. And then, if I understand this correctly, each of the rollups would need a verifier for this one circuit on their platforms. And then, in essence,
Yeah. So they don't really need a very... okay, so let me kind of put it in context. The design is such that this is kind of permissionless. We don't have to have rollups opt into this. Basically, we take in the proofs permissionlessly. Of course, we have to create the circuit or the program that kind of verifies these proofs. the verification is done in Nexus. Now we create these adapters, Nexus adapters that we kind of that you can think of that it runs as a sidecar to the rollup, and either the rollup can run it or we can run it as a service. It's essentially you don't really require to trust the service. It's you can think of it as a relayer for data that we want from the from these rollups, for example. But there is a protocol on top, a messaging protocol on top that kind of coordinates it.
So the relay will commit transactions into each of the rollups that tell it that there was a proof generated, there's an aggregate proof generated, and then this information is available on all of the rollups.
Yeah. I mean, see, basically, there is a little nuance in the sense, like you can consider the rollup as a black box. Now, what we believe is that, like, let's assume who is going to do a cross-chain rollup transaction, who is going to coordinate. The rollup itself may or may not coordinate, right? Like it can be, let's say, abstraction providers or bridge providers or any use, like chain abstraction provider, like let's say a Bungee, for example, and so on, that will coordinate a cross rollup transaction. So essentially, that infrastructure needs to be talking to Nexus. The rollups can do their own job, accept transactions their own way. When it comes to accepting cross rollup transactions, is that component needs to interact with Nexus.
I understand. So it's more of an interop infrastructure provider would integrate with you guys to make it safer or easier to do their job in shuttling information across these chains. So this is, I guess, what you guys are talking about when you say this asynchronous messaging. So it would be another player who would have to pick up and shuttle these messages around. I see. So I get it does strike me as a very lightweight design in the sense that it integrates with other parties and it just does like a very, very specific part of the job, which is sort of like build this aggregate. So the core value would be, or the network effect here would be that the more rollups are in this, like the more powerful that aggregate proof is, right? So I can sort of interact with any of the other rollups, which is how the IP or how the value would grow of the system.
Absolutely. And the beauty is we just need to do one integration per rollup stack. So
Right,
if we integrate a ZK Polygon ZK EVM, it's compatible with all rollups running that stack. Similarly for like ZK Sync, Starkware, and so on.
What are the first projects that you guys are sort of thinking about onboarding? Like, is there a particular type of rollup that you have in mind that would be most sort of useful or most well matched with what you guys are building, or is this wide open?
I mean, at the moment we are receiving it's a lot of interest from teams across the board in general, because really there's a lot of demand in the market for people to be spinning up these Validium, Optimium sort of constructions, which is basically data availability on Avail, proof verification or settlement on Ethereum, those kind of constructions. So there we are getting a lot of demand, and so that is across DeFi, social, gaming, like entertainment, for example, and so on. So there we don't have very specific areas. It's just the demand is across the board. It's just there are just to be honest, very few quality players in the space, and so then the demand is there, right? Rollups can't get enough, so that's there. But in general, we are also very, very bullish on these more non-EVM application specific rollup stacks. So things like Stacker Labs, Sovereign Labs, for example, and these guys are coming up with very easy tooling for building out these app specific chains, right? Like to the extent that with a stacker, for example, you can write a rollup, you can write an actual rollup in TypeScript, and it's a custom state machine, right? Like you don't need to have like a heavyweight EVM execution. Like if you kind of think of it, right? I'm just taking a simple example. It can be more complex, but like an NFT, for example, it's really, if you kind of think of the programming model of an NFT, it is essentially a mapping between a set of token IDs and the owner. And the only business logic mostly is that you can change the mapping or change the transfer from one user to other, right? Like, and so if you kind of think of it, the way that we program this on something like the EVM is EVM has this huge state tree, and we kind of take one segment of it, for example, and then we kind of write the data there, and then we have to read the data. We have to kind of index the whole tree, then wait for logs, for example. And there's so much complex infra around just something as simple as an NFT. And like if you look at something like a stacker, it's like how Web 2 programming is done, right? Like you write a like a database mapping, and then you write the business logic, for example, and you construct a rollup on top of that. So I think what I'm trying to kind of convey is that, of course, these still are in development, but once they come into development, you will see more and more apps or dApps, for example, migrating to these paradigms. And so that's why I take this number of 1,000, 10,000 million rollups, because these are not going to be EVM rollups. These are going to be very lightweight, microservice-like constructions. And so we are very bullish on these.
When are you guys thinking of launching, something you'd call mainnet, where, say for the say DA, Avail DA plus Nexus, which is already like a stack that provides a substantial amount of services?
So the DA mainnet is coming pretty soon. I mean, the final testnet was the incentivized testnet was already concluded. For example, we are just waiting for a few audits to get completed, for example, and so on. So DA mainnet is coming pretty soon. So this will be the DA L1, for example, but also the datability sampling light clients. So including the bridge to Ethereum, which is VectorX. The Nexus thing is, of course, we'll release an MVP in June or July. But the first production grade version should be out end of the year, or probably early next year.
Okay, well, that was a super instructive explanation of the two layers of the stack. I think this is a good place to let the listeners sort of grab their breath back and go and have a look online. So thanks very much for hopping on with me and then explaining what you guys are building.
Yep. Thanks. Great to be here.